Hello, good morning, Bears. How are we doing today? We're all about kinetic energy again. Kinetic means movement. Calisthenics, kinetic. Calisthenics is movement. Kinetic energy. Any movement is kinetic, and guess what? That includes molecules. So today we're tying in a little more science to what we learned yesterday. That when something is moving faster, it's going to be hotter. When it's moving slower, it's going to be colder. But how does that move around? Like right now, I just felt a cool breeze on my face. Is that changing my temperature, or am I changing the breeze's temperature? When I do this and I warm things up, my hands are moving fast. That's kinetic. I am getting some friction going. That's kinetic. I am generating heat. That's kinetic. Oh, it feels good. But what is happening there in my hands to make them warm? Molecules heating up like the water? Molecules heat up, higher kinetic energy, hotter. You lose kinetic energy, things slow down, colder. We're going to tie it all together today, along with averaging, which I'm assuming everybody knows averaging. So we'll do a quick review. There's a lot of slides on it. You can review it if you'd like. Remember, when we skip slides on these amplifies, there's a lot of information that we're covering in different ways, but you can review that information. Let's take a look at our groups. Wednesday, today's lesson is approximately, remember, we're going to look at Ezra's slideshow, I think, and Katsali's is different than Ezra's. If you're adding slides, this will move down, but you can get approximate. Basically, around the kinetic energy slide is where we're going to end. We're going to start around 81. I will show you here. We're going to move our average slide. Remember, we move our concept slides to the top, and you want to do this in order. So we're going to move the average slide to the top, and you're going to average the numbers 12, 10, 7, and 8. Let's pretend like there's billions of molecules, but instead of billions, let's say there is only 12. And if those 12 molecules are moving, and then there you have a 10 molecule moving, and then you have a 7 molecule moving, and you have an 8. And we're talking about the number of kinetic energy. So not 12 molecules, but the molecules are moving at a 12. And we're saying the higher the number is the higher the kinetic energy, which is the higher the heat. So if you're going to average out that heat in the molecules movement, or you could call this different molecules within, there's different ways to think about it. But the goal of this is to average. So we added them up. 12 plus 10 is 22. 22 plus 7 is 29. 29 plus 8 is 37. Now 37 is not an easy number because now you have to divide it in a weird way, so I don't want you to have to do that. So I'm going to go 37. Let's make that a 7. Now we have 36. And this is a mode, by the way, but that's a different story. So 36 divided by 4. What's 8 times 4? 32. What's 9 times 4? 36. So 36 divided by 4 is 9. Our average number is 9. So I just did the work for you there. So you would, but I want you to create this slide writing the average number. So move that to the top. Then you're going to go down and you move the infer concept slide to the top. Another slide, you'll go find it, infer, move to the top, easy wheezy. Just read the definition. We just want it there for reference. Now we're going to move the kinetic energy slide to the top and add visuals. All right, that's pretty basic. Now the kind of the thinking slide here is prediction slide. We want to predict what do you think is going to work best on the system that the school has in place. And we've seen that system. We're going to go look at it right now. Move one of the school models to the top and predict, make a hypothesis, that's the same thing as predict, on which system you think will be better. All right, let's dive into the lesson. Take a look at what an A-level student is doing. This is not just about A's. I really don't even like grades. I want to learn because it's fun to learn. But grades do come along, and if you want an A, you're like Ezra. Now, Ezra's also learning a lot more because he's doing some work. He even gives thanks to Google for the research. So he has a cool title slide. He has what happens to molecules when they warm up. We have water vapor, we have dust, we have water drops, we have cloud droplets, and we have a cloud. And so he's getting a little bit into weather. We're going to tie this into weather soon. When does water freeze? 32 degrees Fahrenheit, yes. This is what we were looking for. We've all been taught that water freezes at 32 degrees Fahrenheit, 0 degrees Celsius. So that was an important fact we wanted. 32 degrees freezing approximately. Fahrenheit. 0 degrees Celsius, 273.5 Kelvin. Didn't even know about Kelvin. I did, but I don't know anything about it. That's not always the case, though. Scientists have found liquid water as cold as 40. Interesting. And even negative 42. So yes, in certain environments, especially if you add salt, things change. When does water boil? 212 Fahrenheit. So remember, Fahrenheit has a 32 for freeze, 212 for boil, 100 for boil for Celsius, 0 for freeze for Celsius. Good job, has a definition. Now he has, do molecules move at absolute 0? No. And he has an example. Good job. So this is bonus now. He has more than he needs, but this is what everybody should have. You should have this molecules from Monday. You should have your freezing and boiling from yesterday, and now we're to today. Thank you, Ezra, for your fabulous teaching tools. Why do things change temperature? Pressure, density. We have different ways, including friction, this trick here. We measure things with thermometer. Notice this one, I believe, has the two different scales of, no, it just has Celsius. I thought maybe it had both. What is happening when the air in the school gets warmer? Okay, now, he's answering the questions already because he's superstar. But now we're diving into what we're learning about. What is the best system? In order to figure out the best system, we need to study the science of how does heat transfer, how does kinetic energy work? Will air warm up water? Will air cool down water? Will water cool down the air? Which is going to impact which? How does this all work? That will help us picking the best system for this school. Now, let's go take a look and review our problem. By the way, I'm now looking at Casali's slideshow, she's done a minimum amount of work, but she did move her molecule slide to the top, and so she's on track. So you want to just go ahead and catch up with yesterday's, and you'll be on track. So we're going to move down to about 82, I'm sorry. Remember, averaging, we've reviewed that. You should have a top average slide. I don't care if you use dogs, cats, the numbers I gave you in groups. Show me that you know how to average. 4 to 5 numbers, make them different numbers. 2, 2, 2, 2, 2. Guess what your average is going to be? 2. Well, 2, 4, 6, 8, 10. 10 divided by 5, 2. What if all your numbers were 5? 5, 10, 15, 20, 25. 25 divided by 5, 5. If it's all the same number, the average is that number. We use averaging when you have different numbers. We have an 8, a 6, an 8, and a 6. Guess what? Probably going to be 7. Let's see. 2 8s is 16. 2 6s is 12. So 26, 28. 28 divided by 4 is 7 times 4 is 28, so 7. Sure enough. Why? Because I had an 8 and a 6, that averages to be 7. I had an 8 and a 6, that averages to be 7. So you can do stuff in your head. But we need to know averaging, so do that slide. All right, let's take a look and review the differences between the heating systems you're evaluating. Water temperature and tank size. So this obviously has a smaller tank, larger tank because it's underwater. Morning air temperature is 11 C. Morning air temperature is 11 C. Water heater pumps in 39 Celsius of water. Groundwater pumps in 30 Celsius of water. So groundwater is 30. Water heater turns this to 39. And remember, we're using water to heat up the school. So that seems obvious. We have 39 degrees here, 30 there. That's warmer, should work better. Is that true? We don't know. We're going to make an hypothesis. We just said that there. Consider the molecules in the two proposed systems. How are they the same and how are they different? So the molecules shouldn't be the same, although these molecules would be moving faster. At this point, which system do you think will warm Riverdale School more? So this is your prediction slide. This is in groups. Move this to the top, drag it all the way to the top, and write your prediction on this slide. That's all you really have to do today is do your concept slides and write that prediction. But let's learn some more. What else would you like to know about the heating systems in order to make a more informed decision about which is better for the school? You do not need to know which system is better yet. You will have multiple opportunities to change your mind as you learn more over the course of this unit. So right now we're just guessing, but let's get some more information before we write our guess. Dear Mr. Chang, I'm worried about your proposal to install a groundwater heater system in my daughter's school. I don't think that the water at temperature of 30 C has enough energy to heat the school. If the school is too cold, the students won't be able to focus on learning. David Lee, so that's a parent the principal received. What do you think energy is? What do you think energy has to do with the heating systems? All right, so energy, kinetic energy. We talked about it, but let's see what they say about it. Energy is the ability to make things move or change. We know that molecules move and that when they get hotter, they move faster. The heating system we recommend should heat the air and make the molecules in the air move faster. Before we can figure out which heating system makes the air molecules move faster, we have to learn what causes the molecules in the air to speed up. Yes, so how do we speed up the air? What causes the air molecules inside the school to speed up? Take a look. In order to learn whether water can speed up the molecules in the air, we're going to watch a video that models a heating system using warm water. So basically, can warm water heat the air? That's the goal. What do you think would happen if the experiment kept running? Well, did we even watch it yet? No, there it is. Let's do this.
Here we see an empty cup in a box with two thermometers. Both thermometers are at room temperature, 22 degrees Celsius. Now let's lift the box and add hot water to the cup. Once we put the box back over the cup, no air can escape. Now let's observe what happens to the temperatures of the water and air over time. We'll speed up the video to see the results faster. Three minutes have gone by. Let's take a closer look at our temperature data. The water started at 89.5 degrees Celsius, and the air started at 22 degrees Celsius. By the end of the experiment, the water temperature had decreased to 66.4 degrees Celsius, and the air temperature increased to 30.1 degrees Celsius. What do you think would happen if we let the experiment keep running?